Good morning, everybody. It is Wednesday, December 2nd, and we're going to be working on some inequality stuff today. We've already started working a little bit. So, what I'd like you to do is take out your notebook, write a couple of these problems down. At the end, there's a couple of practice problems. And as always, since you want to keep things nice and organized, you want to put the date. So, today is the 2nd. And then at the top of the page, you should sign your name in cursive, like you were going to sign a document, and just practice it, because I've found that even with my own kids that they don't have a signature, and you really should have one. So you should do that at the top of your page. Just write your name. Okay. And then we're going to get back to this solving inequalities here. So we've been working on solving inequalities, and there are really just one main idea. Okay. So when you multiply or divide by a negative number, you have to flip the inequality. So that's really the only thing that's different. You guys are great at solving equations. So now it's just practicing, but we're including this one extra thing. And remember that we talked about that it's actually when you multiply by a negative or divide by a negative, you're actually flipping the value on the other side of your number line. So that's why you have to flip the inequality. All right, so let's get back to this one. We want to solve for x. I don't know what your strategy is because I'm not in person, but if this, obviously it's me solving, I don't like fractions. The first thing that I would do is I would multiply both sides by 2. Okay, that's just always my first instinct to do that. And if I do, I get negative 2x is greater than these 2's right here. 2 divided by 2, that makes a 1, and I get x minus 7. Okay, so I'm going to keep on solving for x. I'm going to see what happens. I'm going to get my x's on the same side. I get negative 3x is greater than negative 7. And then I am going to divide both sides by negative 3. Oh, right there. There's your key, right? You divide by a negative. That should be that indication where this is going to get flipped. Okay, so it turns into x is less than 7/3. Okay, so if you make a number line, all you're doing on a number line is you're making your best guess, right? So x is less than 7/3 is really x is less than 2 1/3 approximately, right? 2 1/3. 3 goes into 7 twice. Okay, so it's a little bit more than 2. It is an open circle, all right? And it's everything less than that. Bam, all the way. For interval notation, all right, so keep practicing with that. It goes from left to right. So what's happening on the left is that's negative infinity. So it's coming from the left and it's going to 7/3. Now, open circle, that's a parentheses. Okay. Now, I have one quick question though before we move on. And my question is, why didn't I flip the inequality here? I multiplied by 2. Oh, because I multiplied just by a regular 2. Okay. So when I multiplied by 2, it was fine. I don't need to flip the inequality. It's only when I multiply by a negative. Okay, that's the only time you multiply, divide by a negative number. Okay, so let's see if we can try a couple more of these ones. Okay, for this second one, we're going to define a variable, write an equality, solve each problem. Right, when you have practice problems at the end, you're going to have to write your answers in interval notation. So we'll talk about how you would type in that answer. Okay, so 3/4 of a number decreased by 9 is at least 42. So how about if we call our variable x? So 3/4 of a number. When it's 3/4 of a number, that means multiply. Okay, so 3/4 of x decreased by 9. So decreased means subtraction, right? decreased by 9 is at least 42. Here's 42, but at least 42. So it has to be at least 42. Could it be 42? Yes. But at least the minimum, the smallest amount it can be is 42. Oh, so if that's the least amount, that's the smallest amount, this whole thing has to be greater than or equal to 42. So 3/4 of a number decreased by 9 is at least 42. So the least it can be is 42. So I need that greater than or equal to. Okay, so do what you can when you solve these, right? So if you're solving these by yourself, you can talk through the problem, you can talk through it and ask yourself, what could the smallest value, what's the largest value? Okay, because there is merit in being able to talk through things. And then you're just gonna solve this. I'm gonna add 9 to both sides. And I get 51. Right. Now you decide how you want to do this next part. Do you want to divide by 3/4? Do you want to multiply by 4/3? Me, I always have a very similar strategy pretty much every time. All right. My strategy is to get rid of fractions. So that's the step that I take. So if I multiply everything by 4, I get 3x is greater than 200. And then from there, I just divide by 3. Oh, okay, divide by 3. So x is greater than or equal to 68. Okay, so there's my solution. But if you're going to type in your answer somewhere, say at the end of this Edpuzzle, and it says write your answer as interval notation, you know on your number line that, here's 68, that it's greater than or equal to 68, so we're going this way. In interval notation, this would be bracket 68. But you are not going to be able to just draw it in like that. You're going to have to type it in because it's Edpuzzle, and that's just kind of how that works. Oh, if it will let me do this. Oh, there we go. Okay, so there is a bracket key next to the letter P. So you can do bracket, type in 68, and you can just type in infinity. Okay, that's probably the easiest way to do it. Okay. Great. So I'm hoping that these are working out well and you like these and they're good and you're feeling better. Let's try this next one though and see what happens. Right. So find all sets of 2 consecutive positive integers with a sum that is at least 8 and less than 24. All right. So we haven't done consecutive integers for a while. Right. Consecutive integers mean that you have 2 numbers. And if it's consecutive odd integers, it's numbers like this, like 3. Hmm. Oh, now I know. I don't think the pen's working. All right, let's try that. Okay, so like 3, 5, 7. Right. I just want 2 consecutive odd integers, so I'm just going to write 3 and 5. Okay, so if I want to express this with x, this would be x, and then my next number would be x plus 2. Those are my 2 consecutive positive odd integers with the sum of 8, with a sum that's at least 8 and less than 24. All right, so I know that I'm talking about these 2 consecutive positive odd integers right here, and I want their sum. Great. So x plus 2, there's their sum. I want it to be at least 8 and less than 24. Okay, less than 24, but it has to be at least 8. The least amount it could be is 8, so it needs to be, this sum needs to be greater than 8. Oh, okay. Well, let's see if I can solve that. Oh, so it has to be at least 8. Could it be 8? At least. It could be. So it has to be less than 24, and it has to be at least 8. The least it could be is 8. You have to have that equal sign because it could be 8. Okay. So I have 8 less than or equal to 2x plus 2 is less than 24. Oh, okay. So if you've been in class, you've seen this. All right, this is a compound inequality. And all it means is that this quantity has to be true for both parts. So it means that x has to be less than or equal to 2x plus 2, and 2x plus 2 is less than 24. Okay, so you're going to solve both of these parts and kind of see what happens. So if I see these, I get 6 is less than or equal to 2x. So x is greater than or equal to 3. Or x is less than 11. Oh, so x has to be both things here. X has to be bigger than 3, but less than 11. Oh, something like this. So x has to be less than 11, but greater than or equal to 3. Oh, perfect. Okay, so you get that answer, but wait a second. What does that mean? So that's what x could be. But this was a problem where it said find all sets of two consecutive positive integers where the sum could be at least 8 and less than 24. All right, so this is saying that x could be 3. So if x was 3, then my next number would be 5. So that's one pair, right? So is that true? Is the sum at least 8? Yes, and it's less than 24. But wait a second, it's not the only answer that would work. Okay, what's another odd integer? What's another value for x that would work? Well, not 4, because 4 is even, but I could have 5, 5 and 7. It's two consecutive odd integers whose sum is at least 8, which is true, this is 12, but the sum is less than 24. Oh, great. Are there any other pairs of numbers that will work? Will 7 and 9 work? Two consecutive positive odd integers. The sum is at least 8, yes. And it's less than 24? Yeah. How about 9 and 11? Does that work? Is the sum at least 8? Is it less than 24? Yes. Right? Why can't I use 11 and 13 though? Why is that not an answer? Oh, well, because x is less than 11, so it's not a possibility here. All right, so it has to be less than 11, so it could only be 9. That would be my last choice. So for this problem, you actually get 4 sets of answers here that will work. So when it said find all sets of answers, those are all of them, 3 and 5, 5 and 7, 7 and 9, 9 and 11. Okay. All right, so we have a couple more left. Right. Now I want you to take a minute, pause the video, write this down, and see what happens when you solve this. Okay. Oh, okay, so you're solving this. And what happens? All right. So what happened when you solve this? All right, you solved it all out. You have no x's left, and you are left with 25 is less than or equal to negative 12. What do you think that my answer is for this? Ah, okay. If you have said it is no solution, then you are correct. Kind of looks like a fish. No solution. Okay. So it is no solution. In Delta Math, sometimes they write it as the empty set. Um, but yes, that can happen. Just like when you're solving equations, you can also get no solution. Now, what happens if I change this original? Look what I changed here. What happens if I change this exact same thing and I end up with 25 is greater than or equal to negative 12? What's going to happen to your solution for this? Of course, this is always true, right? Okay, it's always true. There's an infinite amount of solutions. With interval notation, you can write it like this: parentheses, negative infinity, infinity. Okay, so it's always true. There is no there. Everything will work here. All right, so we have one last one that I want to look at because I just want you to think about it and just see what you can do with it. There's the practice. Okay. We're moving on to absolute value inequalities next week. So that's why we're kind of refreshing your memory about some of the ones we've already done. So let's see. Most snakes live where the temperature ranges from 75 degrees Fahrenheit to 90 degrees Fahrenheit inclusive. So that means that it includes those temperatures. Write an inequality for temperatures where snakes will not thrive. Okay, so let's think about where snakes thrive. This is where they thrive. Between temperatures of 75 and 90 inclusive, which means that I include those values. This is where snakes are happy. How do we write an inequality where snakes do not thrive, right? So they don't thrive. Well, let's think. If this one says x is greater than 75, where it doesn't thrive is where x is less than 75. Or where x is greater than 90. So this is where they do not thrive. Those are the way that you write it with set notation, which we've been doing, and this is fine and all good and it's lovely. But if you've been in the classroom, we've done a little bit of interval notation. And I just want to go over how to write that with interval notation. If you wanted to write x is less than 75, it would look like this: negative infinity to 75 parentheses. If you wanted to write x is greater than 90, it would be 90 to infinity. You're good. This or part, because snakes don't thrive when it's less than 75 or when it's bigger than 90, this or thing in interval notation is a big U, and it's called that's the union. It means that both sets of answers will answer this question. Okay, so I just wanted to put those out there to see how you could do. There's 3 practice questions that I want you to try, and then you're just going to submit them on Edpuzzle. They are right here. So if you have, your answers are going to be in interval notation for all 3 of these practice problems. So you can use your brackets, use parentheses. If you need to use infinity, you can just write out the word. That's the easiest way. Okay, once again, if you have questions, come into office hours and we'll see you there.